2.5, equations of lines and linear models. So we're going to continue on with dealing with linear functions and linear equations. And some of this is going to be a review from that. So we're going to look at those three equations that we had for lines. Y is equal to mx plus b, the slope-intercept form, ax plus by is equal to c, the standard form, and y minus y1 is equal to m times x minus x1, the point slope form. So we've got these three equations that we can use, and this can be very helpful depending on what information we are given. First of all, as we talked about previously, we can start in any of these forms and move into the other ones. We generally don't move into the point slope form, but we can go from the point slope form into standard form or the slope-intercept form. We can go from the slope-intercept form into standard form, from the standard form into slope-intercept form, so we can move around with them. And that's actually really handy because it means that we can find out information that we didn't have initially just by utilizing one of these forms as opposed to another. So let's say we had 5x plus 2y is equal to negative 4. So this is obviously the standard form, and given this you're told find the slope and the y-intercept. Find m and the y-intercept. So that's what we're looking to find. Well, this obviously is in standard form, that doesn't give us any of that. So what we can do is we can transform it into the slope-intercept form. That means we want to solve for y. So we're going to subtract 5x from both sides, giving us 2y is equal to negative 5x minus 4. And then we're going to divide both sides by 2. So y is equal to negative 5 halves x minus 2. Negative 4 divided by 2 is negative 2. Now we're in the slope-intercept form. So m is equal to negative 5 halves. And the y-intercept is going to be 0, negative 2. So as we can see, that's really handy, just a little bit of manipulation, all of a sudden we found out this information. So, nice trick there we can do with that. Other things we can do by knowing these forms is we can start with 2 points. Because we realize that, obviously if we have the slope and the intercept, we can put it in this form, then we can move it into standard form. If we have a point and a slope, we can put it into this equation, and then we can get it into either of the other forms. If we have it in standard form, which is what we just had, we can move it into the slope-intercept form and find things that way. But what if we have 2 points on this line? I have negative 2, 5, and 3, 1. 2 points on the line, and now I want to get an equation for the line. Well, you may look at that and go, well, wait a second, if you give me a slope and the intercept, but here I don't have the slope or the intercept. If you give me a point and the slope, but I have 2 points, but I don't have a slope, and standard form, you just kind of get to standard form by using one of these to get there, right? So what do? Well, we have 2 points, which means we can find the slope. Once we have the slope, we can use either one of those points and use the point slope form. And then we can convert it into whichever form we want to do. So why don't we take this and get an equation in standard form? So that's what we're looking for. We're looking for an equation for a line in standard form that passes through those 2 points. So first, let's find the slope. M is equal to, remember that's change in y over change in x. So 1 minus 5 over 3 minus negative 2. 1 minus 5 is negative 4. 3 minus negative 2 is 3 plus 2, or 5. So our slope is negative 4/5. So that's a good start. And then, now that we have a slope, we just need to choose one of the points and put it into this equation. So I'm going to choose this one just because it's the first one. Why not? So y minus 5 is equal to negative 4/5 x minus negative 2. Make it so I can actually see that negative 2. Point slope form accomplished, but I want to get into standard form. So let's distribute this through. Y minus 5 is equal to negative 4/5 x. Minus the negative is positive, so 2. So I can take negative 4/5 and multiply it by 2. Minus 8/5. That's a good start. I just want to make that look more like a 4. There we go. But I've got to get these into position so I can combine my constant terms and I can get my x values in the same spot. So I know I like leading coefficients that are positive, so I'm going to move x over to the other side. So I'm going to add 4/5 x. So 4/5 x plus y is equal to, and I'm going to add 5 to both sides. Well, wait a second, this is 8/5. That's 5. Well, 5 is 25/5. So 25/5 minus 8/5 gives us 17/5. Now, what did I say about standard form? We don't like to leave it as fractions. We like to put it as integers for our coefficients. So I'm just going to, I look and I see I've got 5 and 5. Remember when we were dealing with rational equations that I said we can get the common denominator, then we can wipe out the denominator and it puts us into a nicer equation? Same thing here, common denominator 5. So if I just multiply through this whole thing by 5, I end up with 4x plus 5y is equal to 17, and so I went from 2 points on a line to an equation in standard form. Now what I want to do is I want to do this exact same thing again, but I'm going to do it at the other point, just to see what happens. I still have that slope, I'm just going to be plugging in 1 and 3. for this. So I'm going to do it right next to it. Hopefully I won't be blocking the view too much. Y minus 1 is equal to negative 4/5 x minus 3. Distribute it through. Y minus 1 is equal to negative 4/5 x plus 12/5. I'm going to move the x over to that side. So I'm going to add 4/5 x. 4/5 x plus y is equal to, now I've got minus 1, so I'm going to add 1. We're dealing with fifths, so I'm going to add 5/5, which gives me 17/5. And then again, I'm in fractions and I want to get into integer. So what I'm going to do is just multiply through by 5. 4x, let's make that actually look like a 4. So 4x plus 5y is equal to 17. And because all is good in the world, notice that those two equations are the same. So it doesn't matter which point you use when you are getting the equation into standard form, or I should say when you're putting it in point slope form. If you have 2 points on the line, find the slope, use either one of those points, and it's going to give you a correct equation for the line. Which means if you then move into standard form or slope-intercept form, you're going to come out with the exact same equation. So it works either way. Just wanted to make sure that we demonstrated that. So let me get this board cleaned off. Now I'm going to get those equations out of the way because at this point you've seen them long enough and you can refer back to them if necessary. Hopefully you've even written them down somewhere. So we have that. Well, what if we have a graph of a line? Okay, so I've got my grid. That took long enough to do. Key anytime you use markers to make sure it squeaks properly. So now I have this graph. And I have a line here. And I want to find the equation of this line. Well, I happen to see those 2 points. Well, if I have 2 points on a line, I can do what we just did. So we can take those points, we can find the slope, and actually we can save ourselves a little effort because since we are looking at the graph here, we don't have to get really fancy with this. The slope of this graph, the rise is 1, while the run is 2. The change in y is 1. The change in x is 2. We see it's increasing, so it's a positive slope. So the slope is 1/2. I didn't have to put anything, real effort into that. I didn't have to go through and do my subtractions. I was able to just look at the graph. So that's a nice thing there. We just were able to look at it and count as opposed to having to actually subtract. Not that subtracting is that difficult. Now that we have that, we have these 2 points. In fact, let's write down these 2 points. We have negative 2, 0, negative 2, 0, and we have 0, 1. So if I want to get an equation for this line, there's a couple ways, well, there's a few things we could do, but a couple ways we could do it is, one, we can use the point slope form like we just used previously, or we could recognize here that one of these points is the y-intercept. And recognizing that, we can go, oh, y is equal to m, 1/2 x, plus b, the y-intercept, 1. And we're done. We just went from a graph to the equation. We could do the same thing by going through in point slope form and everything, but why? Why put through the extra effort if we don't have to? I'm not a fan of wasting energy. If there's a quick, easy way to do it and get it right, I'm going to take that quick, easy way. Now, as we talked about before, we may have horizontal lines and vertical lines. Horizontal lines have a slope of 0, and vertical lines have a slope of undefined, right? It's some value divided by 0, so it's undefined. But if we're dealing with the equations, if we have y equal to b, so y equal to some value, no matter what x value we put in, we're going to get the same y. That's the equation for a horizontal line. So that's a horizontal line. And if we have x equal to b, that's the equation for a vertical line. For a horizontal line, we know that the slope is equal to 0, and for a vertical line, we know that the slope is undefined. So pretty straightforward. So what if I ask you to graph that? Well, put another one of these grids up here. So I get the equation y is equal to -3. Then no matter what x is, y is going to be equal to -3. So it's going to be a horizontal line that passes through -3. So there we go. And that is the line y equal to -3. So pretty straightforward. If we have x equal to 2, then we're going to go where x is equal to 2, and we're going to have a vertical line. So there's x equal to 2, because no matter what y value you have, x is going to be equal to 2. And here's y equal to -3, no matter what x value you have, y is going to be equal to -3. So pretty straightforward vertical and horizontal lines. Now, getting into this a little more, and looking into slope and what it tells us, we can have different things happen with lines. If we have two lines on the same plane, which is a flat surface, right? There are certain things that can happen. If we have two lines on the same plane, they're either going to cross over one another, which we call intersect, right? They're either going to intersect, or they're not going to intersect. If they don't intersect, they're parallel. So if they don't intersect, they're parallel, which means that there's a constant distance between the two of them. The distance between them does not change. It also means if they're parallel, since there's a constant distance between them, they're both rising or falling at the same rate, which means that the slope of the first line is equal to the slope of the second line. So if we call this L1 and L2, line 1 and line 2, if these lines are parallel, then their two slopes are going to be the same. Now their y-intercepts will be different, but their slopes will be the same. That's how they stay constant. If they intersect, then they don't have the same slope. But there's even a special case of intersecting when L1 and L2 are perpendicular to each other, meaning that their intersection point forms a right angle. When they are perpendicular, their slopes are negative reciprocals. So m1 is equal to negative 1 over m2. They're negative reciprocals. Or you can say that m1 times m2 is equal to negative 1. So if you multiply the two slopes together, you will get negative 1. Or they're negative reciprocals, which means if you have the slope of 1, just flip it and put a negative sign in front of it or negate it, and you get the slope of the other. So what this allows us to do is we can now look at the equations of two lines and determine whether they are parallel, perpendicular, or just intersect. Because remember, they're going to do, perpendicular is really a special case of intersection. So we're checking to see, are they parallel or do they intersect? And if they intersect, are they perpendicular? And we can do that by looking at the slopes. We don't need to do anything else. So if I have two lines that the equations are just given in random form, so not even necessarily one of those three forms that we had, it's just a relationship between them. If I have 5x plus 2y is equal to negative 4, and I have 6x is equal to negative 15, sorry, I meant that to be 6y. 6y is equal to negative 15x minus 12. And I want to determine, do these intersect or are they perpendicular? If they do they intersect or are they parallel? If they intersect, are they perpendicular? So to do that, we can put these into a form that's going to give us our slope. So we want to go into the slope-intercept form. If the slopes are this, and then we can compare slopes. If the slopes are the same, then they're parallel. If the slopes are different, then they intersect. If the slopes are negative reciprocals, then they're perpendicular. So let's take a look at this and see. So I'm going to solve for y and get them into slope-intercept form. And I'll start with this bottom one first because it happens to be pretty close. So y is equal to, I'm just going to divide by 6, negative 15 over 6x minus 12 over 6. So y is equal to negative, if I divide by 3, 5 halves, x, divide by 6, minus 2. So I have a slope of negative 5 halves. And if I take this one here, then I'm going to move this over to the other side. I'm going to make it 2y is equal to negative 5x minus 4. I'm going to divide by 2. Y is equal to negative 5 halves x minus 2. And I find the slopes are the same. But not only are the slopes the same, so are the intercepts. So the slopes being the same, that tells us perpendicular. Sorry, keep saying perpendicular when I say parallel. It tells us that they're parallel. But since the intercepts are the same also, it tells us they're actually the same line. So I guess we have 4 things we have to worry about. First, are the slopes the same or are the slopes different? If the slopes are different, they intersect. If the slopes are the same, then they're either parallel or the same line. If the slopes are different, then they intersect. If the slopes are negative reciprocals of each other, then they're perpendicular to one another. And in this case, we found they're the same line. What if we have y equal to negative 3x plus 2, and y equal to 3x plus 7. Are these lines parallel, or do they intersect? And if they intersect, are they perpendicular? Now I made this nice and easy. We can just look directly at the slope. We have a slope of -3 and a slope of 3. So the slopes are not the same, so they're not parallel. So the question is, are they perpendicular? We have -3 and 3. Well, if I have -3, what's the reciprocal of the negative reciprocal of -3? Well, it's going to go from negative to positive, and that 3 is really 3 over 1, so that's going to go to 1/3. So since the slope of this is -3, then I would need the slope of this to be positive 1/3, and it is not. So these lines intersect, but they are not perpendicular to one another. But that's our method of determining whether they are parallel, whether they are perpendicular, whether they intersect or not. It's just simply looking at those slopes. Now, another cool thing that we can do with this is sometimes you want to create lines that are parallel to one another, or lines that are perpendicular to one another. So let's try this. If I have the equation y equal to 2x plus 1, and I want to make a line that is parallel to this, so parallel, and for those of you who are unaware, in graphing and such, parallel can be denoted by two vertical lines side by side. So that's saying parallel. So just a symbol that you may see at times is L1. L1 is parallel to L2, right? Line 1 is parallel to I2, to line 2. So just keep that in mind. But we want it parallel, and we want it to pass through the point -3, 4. So we want a line that is parallel to this, that passes through the point -3, 4. First, let me just make sure that -3, 4 is not a point on this line. 2 times -3 is -6, plus 1 is -5, so y equals -5, so no. It is not a point on this line. So we want to create a line that is parallel to this, but passes through the point -3, 4. Well, how can we do that? Well, we have the slope, don't we? I'm going to switch colors to denote that this is what we're actually doing. So we can say that the slope is 2. And we want a line that with a slope of 2, because that's what it takes to be parallel, and that passes through the point -3, 4. Simply enough, we can use the point slope form. I don't need the parenthesis there. Y minus 4 is equal to 2 times x minus -3. And there we go. We now have an equation for a line that is parallel to this, that passes to the point -3, 4. And we could take it a little bit further and put it also into the slope-intercept form so we can see where it crosses the y-axis. Distributed through, y plus 4 is equal to 2 times, actually, 2x, minus the negative is positive, so plus 6. Subtract 4 from both sides, y is equal to 2x plus 2. So y equal to 2x plus 1 and y equal to 2x plus 2 are parallel lines. This line passing through the point -3, 4. What we can also do, and remember all we did with this was we just said, okay, what's the slope of this one? We need another line that has that slope but goes through that point. Another question we can ask is, what about creating a line that is perpendicular perpendicular to this line that passes through the point negative 3, 4. Perpendicular, you can use an upside down T. Shows kind of you have these right angles and it's creating that. So that's perpendicular, so I can say L1 perpendicular to L2. Well, we know that for two lines to be perpendicular, their slopes have to be negative reciprocals. So this has a slope of 2, I'm just going to call that M1. My new line needs M2, a slope that's the negative reciprocal, or negative 1/2. Remember, 2 is just 2 over 1, so the reciprocal is 1/2, so negative 1/2. Now that I have that slope, I have a point, and same thing, y minus 4 is equal to negative 1/2 x minus negative 3. And then if I want to put it into slope-intercept form, y minus 4 is equal to negative 1/2 x minus 3/2. And then add 4 to both sides. Y is equal to negative 1/2 x. We've got minus 3/2. 4, and we're going to add 4. 4 is 8/2. So 8/2 minus 3/2 gives you 5/2. So plus 5/2. And we see we've got a slope of negative 1/2 and a y-intercept of 5/2. So put it in that form. So pretty cool. We can start with one line, for one line, and we can come up with lines that are parallel to it or perpendicular to it. We can choose a point and say I want it to be parallel to it and go through this point, or I want it to be perpendicular to it and pass through that point. Just by knowing that if they're parallel, the slopes will be the same. If they're perpendicular, the slopes will be negative reciprocals. Okay, so now that we have that, don't forget that you have tools available to you, such as a graphing calculator or Desmos.com or some other utility. So it is possible for you to graph these things and take a look and say, hey, where do these two lines intersect? Or graph the line that's perpendicular to it. Or look at two things and say, hey, are they parallel or are they perpendicular? But one thing we have to be aware of when we're using these electronic devices is that you are limited to a certain resolution on that screen. And that means that two things could look parallel or look perpendicular and not actually be so. If you remember when we were plotting when we had 3 points and we were determining whether they were collinear or formed a right triangle, we said be careful, don't just draw them and say, hey, that looks like it's such and such. Do the math just to make sure. Do the math just to make sure, because they could very well look like they are parallel, but they aren't. You could have a line like this and another line like this, and they look parallel, but you can see that that distance and that distance are not the same. So they may look very close, especially the smaller the screen you're going onto a calculator screen, very hard to tell whether they're really parallel or whether they're really perpendicular. So just keep that in mind. Okay, so just a couple things that I want to point out to you, and so I got my little sheet so I can get it into words and make it clear. Modeling data. So we have linear models. If you're trying to model data, what you can do is if it's linear data, and yes, if you've taken statistics, you know that there's actually ways to do this. So linear regression, and you can actually come up with the equation that's the best fit equation. But if you just have a bunch of data points and you want to estimate the graph, what the equation is for the line, maybe you can't tell for sure all those points. It's one thing if you're given a bunch of data and you plug it in, you can use an equation. But if you just have something like this, where you got a whole bunch of data points here on your graph, one way that you can estimate that and come up with a linear model for it is just choose 2 points that seem to fit this pretty well. Like I see this one here and this one here seem to give me a pretty good estimation. Now, since I have those 2 points, I can come up with the slope, and I can use one of those points and use the point slope form to come up with a linear model for our data. So that's one thing that we can do. I'm not going to go through it because it really is that straightforward, that choose 2 points that look like they'll give you a line relatively straight through it, and just use that to get the slope, and choose one of the points and put yourself into point slope form, and then from there you can go to slope-intercept form, or you can go into standard form. So a really handy tool, especially if you just have a bunch of data here that you're going to have to guesstimate anyway. As I said, if you're given a bunch of data points and you have the ordered pairs, there is a method that can be used to come up with the best fit line. If you're just given a bunch of points on a graph, estimate somewhere in there 2 points and come up with a line. So if we're talking about solving a system of linear equations with one variable, then we're basically ignoring the other variable. So we can say if we have y1 is equal to 3x minus 2, and y2 is equal to 5x plus 4, and then we say y1 is equal to y2, we can solve and find what value of x makes that true. And we can do that by setting them equal to each other. So 3x minus 2 is equal to 5x plus 4. Subtract 3x from both sides. 5x minus 3x gives us 2x. Subtract 4 from both sides. Negative 2 minus 4 gives us negative 6. Divide both sides by 2. X is equal to negative 3. So when x is equal to negative 3, y1 is equal to y2. 3 times negative 3, negative 9, minus 2, negative 11. 5 times negative 3, negative 15, plus 4, negative 11. So we just solved that system of linear equations in one variable to find that when x is equal to negative 3, y1 is equal to y2. And that finishes up equations of lines and linear models.